First Stick Challenge allows robots to take the shape of pretty much anything a team can dream of, but almost all of the most competitive teams in FTC follow the same pattern: custom manufacturing. My name is Nitin from Teams14525, and this is a crash course into manufacturing for rookies. Tears has been running for over 6 years, and we've accomplished quite a lot in that time, and we'd love to pass on our knowledge in terms of manufacturing through this workshop and deeper dives coming out on our YouTube channel, so stay tuned for that. So why do we need manufacturing in FTC? Custom manufacturing, unlike standard commercial off-the-shelf parts, allow you to have a more flexible design with massive weight reductions and a faster turnover time from CAD to assembly. There are 3 main types of manufacturing that are commonly used in First Stick Challenge: 3D printing, CNC machines, or outsourcing your parts to a company, and we'll do a deep dive into each one. 3D printing. Before we actually talk about the types of 3D printers and all that fun stuff, you need to learn how to actually prep your part in a process called slicing. After you finish CADing your part, by the way, there are a ton of resources online to learn how to CAD in your software of choice, whether it be Onshape, Fusion 360, or even SolidWorks. Export your finished product as a .step or .stl file, and then export to your printer's software and slice it into a format the printer can read using the presets available. Based on what printer you buy, you could easily find software for your printer on the manufacturer's website or online. There are 2 main types of 3D printers that are used in FTC: bed slingers and Core XY, both of which are very viable. What does bed slinger actually mean though? Every 3D printer we'll talk about today has a similar process for actually printing, with a metal extruder which pushes rolls of plastic filament through it to melt the plastic, and a heated bed which allows the parts to stick better to the print bed. The main difference comes in when we talk about the movement of the extruder and print bed. In bed slingers, the extruder moves along the Z and X axis, and the print bed moves along the Y axis. We'll break our bed slingers up into a lower budget and higher budget options, but both of these categories are still very viable options. On the lower budget end of the spectrum, we have the A1 Mini. This is a very viable option as Bambu Labs is a pretty respectable brand in terms of performance. At $200, the A1 Mini has auto calibration, active flow rate compensation, quieter motor noise, a textured PE plate, which is great for easily removing your prints from your bed, and a 14-minute speed print benchmark, and all these other cool specifications, including the ability to start and stop prints from wherever you'd like using the Bambu Labs app. The A1 Mini is a very viable option for anyone looking for an easy plug-and-play option. However, the print bed is on the smaller side at 180 by 180 by 180 mm. A secondary option is the Sobol SB06, also at $200 USD. Just similar specifications, a bit lower performance than the A1 Mini with a 35-minute speed benchmark, a significantly higher print bed size at 220 by 220 by 250 mm. From Prusa to 3D, we have the Prusa Mini at $429 USD. Quick note, Prusa has both a sole US reseller and subsidiary, Printed Solid, and their main headquarters based in Europe. So if you were in North America, it'll be cheaper to buy from the reseller Printed Solid. The Prusa Mini does come at a premium for a lower print bed size at 180 by 180 by 180 mm. However, the print Prusa's consistency is unrivaled and has been in the printing space for well over a decade. The Prusa, however, doesn't have a stock Wi-Fi printing option. However, there is the Prusa Connect app, which has similar features to the Bambu Labs app. Now, onto the higher end of bed slingers. This is really just the MK4S Plus from Prusa 3D. The MK4S Plus is a successor to the MK3 series, which you can see here. Now with the native Wi-Fi capabilities, advanced cooling with a 250 by 210 by 200 mm print bed, the MK4S offers all the consistency of the Prusa Mini, except with faster speeds and higher reliability. The MK4S Plus is really the flagship for bed slingers, so if you're looking to buy one of the best bed slingers out there, the MK4S Plus is the way to go. Core XY. What is Core XY? Core XY printers move the extruder along the X and Y axis, and the print bed moves up and down along the Z axis. Traditionally, Core XY printers are faster than bed slingers, but are generally on the higher end in terms of budget. So like the budget floor for Core XYs usually start at around $500 at the bare minimum for a good quality Core XY, as opposed to bed slingers, which you can find for as low as $200. On the mid-range budget, we have the Bambu Labs P1P at $500 USD. The P1P has great accuracy with an 18-minute benchmark and a 256 by 256 by 256 print size, supported by the Bamboo Slicer and accompanying Bamboo Labs app. We would highly suggest you buy these accessories along with the printer for better quality and speed prints. The P1P comes pre-assembled, other than the accessories, as an option for FTC teams who plan to mainly print in PLA and PETG. After buying accessories, the total price would be around $600 USD. You can buy the actual printer itself for $500 USD, but after you buy all the accessories, the price does go up, and we highly suggest you do buy the accessories. If you want to print with other materials other than PLA and PETG, you can buy the P1S at $600 USD, which basically is the P1P but has an enclosure and comes with a fan, along with other things that allow you to print more toxic filaments like TPU or carbon fiber, which requires certain environments for them to be in order for you to not inhale toxic chemicals, especially in carbon fiber, which can be dangerous if you're printing it without a proper enclosure. So I highly suggest you look into the safety precautions that are required for printing materials like that. On the higher end of Core XY, there's the Bamboo Labs X1C. It has a few more bells and whistles, a bit faster and higher quality than the P1P, but honestly, at more than $1,200 USD, we'd say buying two P1Ps or two P1Ss are a better investment than just buying one really good printer, because the speed of P1Ps and X1Cs are fairly comparable, and you're only going to really see a big difference when it comes to exotic materials or really niche print cases. So for most FTC uses, having two fast printers, especially in crunch time, is really important. Keep in mind this list will most likely be outdated in a year or two, so we highly suggest checking out the first documentation for an updated recommendation list in probably 2 years. Now that you've gotten your printer, we have to find what we actually need to print with. There are three main filaments that an FTC team may need: PLA, PETG, and TPU. PLA is the most common and generally the cheapest, and can be used in a majority of parts without much worry. However, be aware that PLA isn't great under high shock loads. However, with proper designing and factoring this in, you shouldn't see much breakage. PETG is a similar filament, however, it has a higher tensile strength, which basically means its resistance to breaking under tension, or if you put shock on it, and it's generally more flexible than PLA. This filament is great for parts where you know there's going to be a lot of shock load. Now, many teams may require a more flexible part. If that's you, then TPU is a filament you need. TPU is a more rubber-like filament which is very flexible and often used in roller-type mechanisms due to the bendable properties it has. TPU works great under shock and is very viable for these scenarios. Primarily, teams use the 95A durometer version. Durometer is a measure of the TPU's hardness. Of course, there are other filaments out there like ABS, nylon, and carbon fiber, but for a majority of rookie teams, these are not really needed and overall require a lot more experience to produce a usable part, and in some cases, for example, with carbon fiber and nylon, are also toxic if you aren't using it properly. So make sure you research before you buy these types of materials. CNC routers. Before we continue here, we just need to warn the viewers that the chance of getting hurt when using CNC routers are a lot higher than 3D printers. So proper setup and precautions is very important. Okay, with all the red tape out of the way, what actually is a CNC router? A CNC router is a computer-controlled cutting machine which uses a cutting bit on a similar setup to the bed slinger printers we talked about earlier. Different cutting bits and motor speeds can help you cut different types of materials. To control a CNC router, you will need to cam your parts. This workshop isn't quite long enough to learn how to cam parts, but there are great guides online to learn how to do it for your machine and your software. For example, Fusion 360 is what most teams use to cam their own parts. But what machine should I spend my money on? On the lower end of the budget, we have the MP-CNC, which stands for Mostly Printed CNC. The CNC is, you guessed it, mostly 3D printed. The MP-CNC is an open source CNC design created by V1 Engineering. It's hard to say the specs of the MP-CNC because of it being very customizable to how you want to build it. While this is more of a DIY CNC machine, it is definitely easier to source parts for it using V1 Engineering's online guide, and overall it's cheaper, with the price being usually under $700. But it's still viable as a dedicated CNC router for smaller parts. There's a huge community, so creating your own MP-CNC isn't too difficult, but it still isn't for everyone. The CNCs I'm talking about past this point will all exceed $1,100 USD. If the investment of a reliable CNC router like this is too high for your program/team, we highly suggest using an affordable and reputable laser cutting company like Fabrics to cut or bend your parts for you. Fabrics is based in California and has free shipping all across the US. They also do international shipping on a case-by-case basis. You can also get 5% off your Favros order if you use discount code FC14525 at checkout. Now, moving on to the CNCs we would recommend teams invest their money on. Omio CNCs are by far the best value for price. At $2,299, you can pick up an Omio X6 2200. This is a machine that our team primarily uses and is very much capable on its own, and it's what most of the FTC community use. But at a steeper price, running close to $2,799, you can buy an Omio X8 2200 from West Coast Products. Overall, the X8 is everything you'll ever need from a CNC router and FTC applications, widely used in the FRC community. The Omio X8 has an unrivaled reliability and power at its price point. I will say that both of these CNCs are not plug and play. You will need to have a lot of previous experience, and I'd highly just suggest having safety precautions, mentors, and other things to just kind of like streamline your process. There are a lot of great guides online to help you learn what bits to use, and along with that, we'll also be having a deeper dive on our YouTube channel to teach people about these different techniques that you need to use. Unfortunately, we don't want to go too far into our workshop, so we do have to cut it close here. This is Tearbest14525. Thank you for listening to our workshop. If you have any questions about anything that we talked about today, or you have done everything in this workshop and you want to get a deeper dive, be sure to check out our YouTube channel, or you can send us an email at tearbest@terraedu.org. Thank you.